Hi, everybody. Welcome back to Between the Vines. I am Jennifer Phillips Russo, Cornell Viticulture Extension Specialist for the Lake Erie Regional Grape Program. I am here with my co host, Andrew Holden. Hi, Andrew.
Hey, Jen.
So today is July 22nd, 2026, and we have one of our very special guest speakers with us, Dr. Terry Bates. You didn't even smirk when I said that, Terry. We invited him to come on today because this past June, we had the American Society of Enology and Viticulture National Conference in Boise, and they tagged along or combined it with a symposium for the high res nutrition SCRI that was going on. And unfortunately, Terry was unable to attend and give his presentation.
That one I will smirk at.
So we've asked Terry if he would actually do it on our podcast, and then we can share it with everybody so that they could see possibly what was linking all of the pieces together at that symposium. So thank you for being with us.
Thanks for having me. I'm sorry I couldn't make it to the meeting.
Oh, we're all sitting here. Yeah, so you were very missed.
I was very sick.
I know. I didn't want to say it for everybody.
And it wasn't the lettuce. This was before the lettuce thing.
Oh, my heavens. So do you want to just pull up? Because this will also go on YouTube so people can access this during the video.
Yeah, so I'm going to give the talk I would have given at the ASEV meeting. So it's what I would have said. There's a family joke in my house. So it's on my wife's side of the family that they were playing a board game, and it was one of these. My nephew was asked a question about like what you wouldn't say to your father, and he said something very derogatory, and he's like, "It's what I wouldn't say." So this presentation, this is what I would have said if I was there.
Really, thank you for taking time out of this busy summer to do it for us, because I knew there were a lot of people missing this at ASEV and that symposium. So this will be an opportunity for them to see it. So you can share your screen whenever you're ready.
Right.
Do you mind us interjecting questions as we go along?
No, that's fine. Yeah. And yeah, this gives us opportunity, I hope, to slow the presentation down, because usually when I'm at a meeting and it's like bang, 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 maybe we can slow down a little bit and explain some of these slides a little better. Let me share my screen. Okay. So thanks again for having me on the podcast for today. This is the presentation I would have given at ASEV. So my role on the High Res Vineyard Nutrition Project was to take any kind of spatial data that we could get from the sensors being developed and from the tissue nutrients that were being sampled, those models that were being created that I hope you heard about during some of the other presentations. My role is to take that information and understand what the spatial maps of vineyard nutrient supply, uptake, and demand are, and come up with a variable rate fertilizer plan for that, and then apply variable rate fertilizers. And we are still trying to look at the result. So I think one of the themes that you're going to hear me talk about is we try to induce these nutrient deficiencies in the field, and they'll take like 4 or 5 years, depending on your soil conditions and your vine growth and everything. It takes a while to get those nutrient deficiencies to show up. And so we're into our 3rd year of a variable rate fertilizer trial right now. And I think we're just starting to see some of the effects that we're picking up in canopy reflectance. So I'll talk about that like right at the end. So let me get going. So first of all, of course, thank you to all the collaborators that were on the project. Marcus Keller ran an excellent project. Patty Skinkus really kept the glue together on this team with the extension and trying to, she really led the organization of the symposium and was really just an excellent leader along with Marcus to, keep the industry and the researchers together and keep the project on track and try to have a cohesive message at the end of the project. So thanks to them. My role again on the project is, and if you've been following the Efficient Vineyard project for the past 10 years, we follow this measure, model, manage approach, right? I don't really care where my spatial data comes from, right? Satellite data, drone data. We do a lot of work in our vineyards with ground-based sensors that we mount onto tractors or ATVs, drive them through the vineyard, hooked up to a GPS antenna and a data logger to collect spatial data. We even have soil sensors, same deal. So I'm kind of agnostic when it comes to like where the data comes from. I just want to have good spatial data and have a kind of understanding of what that spatial data should be telling me, right? Like if I'm using a soil sensor and it's giving me soil EC, okay, that's giving me an indication of like soil clay and clay content, and that viticulturally means something to me. I'm not trying to take, I don't know, say an NDVI of the canopy and say something about the soil about it. So we try to understand what those sensors are indirectly telling us, and we validate that to make it a direct measure. So all the sensors that we use are relative sensors. They give you a high, medium, low, nice, pretty color map. And we try to make sense out of that color map by doing in-field sampling. We use... there's spatial data software out there that you can use. We use the MyEV software, and we developed that for this purpose to help growers collect field data, but also to understand, and I always bring this up, it's an outreach tool. It's supposed to help growers understand the process of how do I collect data, how do I process it, and then how do I validate it so that I can get a meaningful map. And again, with the world of AI coming up, a lot of this stuff is going to be, push a button and it's going to go, right? But it's your vineyard and you're a vineyard manager. You should understand what it's doing, or it can make some really big mistakes. So that's what the MyEV software is about, right? Collect the data, map it, see what the spatial pattern is, sample against that spatial pattern, and try to turn that map, say, into a canopy fill map or a soil nitrogen map or a yield map. So we have these different tools, and it can also go on your cell phone, so you can carry it around in the field while you're collecting data. It's like a little electric notepad for you. And
I use it all the time.
Once we collect that spatial data and do our validation, so we have some viticulture maps to work with, then we make decisions, and we try to apply those decisions variable rate in the field. And again, with respect to this project, we work with variable rate fertilizers, and I'll show you how that works towards the end of this presentation. Okay. The other thing, if anyone has listened to me over the last 28 years talk about nutrition, I always talk about supply, uptake, and demand. So when you're evaluating your vineyard for its nutrient status and like how you apply variable rate fertilizers, you need to take a look at supply, uptake, and demand. Again, my degree is from Penn State University, and my professor was Jonathan Lynch, who was a plant nutritionist. And I took his course, and this is how the whole course is broken down. There's a whole section on nutrient supply and soils, uptake with respect to plant physiology and nutrient uptake and competition of ions in the soil. And then demand depends on what you're growing, what's your crop size, and how all that works together. And you have to integrate the information there to come up with a reasonable answer to how you're going to manage your vineyard holistically, I guess. So we have target values for all of these different things, right? 3 to 5% organic matter for most vineyards, soil pH of 5.5 to 6.5. That's from soil pH work we did with Concord years ago. Everyone has a little bit different bent on the tissue analysis and what the ranges are, and I think one of the big things that came out of this project is like we don't all agree on like what the optimum tissue values should be. And that was kind of part of the project, was if everybody was collecting tissue, if I was collecting Concord tissue at Bloom and Veraison in New York, and they were doing Pinot Noir in Oregon and Cabernet Sauvignon in California, that we could compare all those and try to come up with a consensus, or make the decision that it's a little bit different for different varieties in different growing regions, which is also a good thing. And then
Did you make a
demand.
decision?
What's that?
Did you make a
Extension?
decision?
Uh, no, we'd have to talk to Marcus Keller. That was kind of his part on the project. Again, I work very closely with Concord, and hasn't been any data I have collected yet that really has moved the needle on any of these numbers. If anything, my nitrogen values may actually be too low for high producing Concord vineyards in New York and Pennsylvania. Like,
Huh.
yeah, I think I have a graph that shows that, so it'll explain it a little bit better. Also, again, Ravaz index, yield to pruning weight ratio, or leaf area to fruit weight ratio is what we consider crop load. How crop stressed is your vine? And, again, if you heard me talk on this subject before, too, like, it seems to be a universal thing, right, around the world, that a Ravaz index of around 8 or 8 to 10 will constitute a balanced vine pretty much no matter where you're growing it or what you're growing. It really then comes down to economics for Concord juice grape guys, and for other grapes that are somewhat in what I would call a commodity market, right? I'm getting paid for tonnage. I want to push that tonnage as high as I can. So how high can I push it and still like maintain vine size so that I can have a consistent crop year after year? So that's why juice grape market, the Ravaz index, we tend to say, okay, 15 to 20. It's pushing it, definitely. But that's where we can get the highest crop possible, get it ripe, and still have no major change in pruning weight for the next year, so that we can come back with another consistent crop. A lot of wine people would say, that's way overcropped.
May I actually ask a question in regards to what you consider a major change? And
In
let's
what?
talk about the juice market. Like, what would
Oh, and then in the nitrogen?
know in the pruning weights to adjust the Ravaz
Oh,
index?
so yeah. So we published a paper on this, and I based it off of 12 years of pruning and thinning work that we had done, and measured the Ravaz index. And we know with Concord, if you hit a Ravaz index of 15 to 20, so if I start off with a 2-pound vine and I have a Ravaz index of 18, I'm still going to have a 2-pound vine. I'm not going to
Okay.
gain or lose pruning weight.
Mm-hmm.
If I have a Concord vine and I have a Ravaz index of 8, I will gain pruning weight for the next year. And so, a little sidebar, and you can drink, because I'm going to mention Nelson Chalice. So the world of Nelson Chalice he said, like, you should only have for Concord, and for any other grape, like, you should never have a Ravaz index of more than 8 to 10. And he lived in a world where he was constantly trying to build vine size. And I would agree with the statement. If I have a Concord vineyard in New York and my pruning weight is too low, say I'm running a vineyard and I have 1.5 or or 2 pounds of pruning weight, right? And I want to have 3 pounds of pruning weight. One of your tools in your toolbox, one of the levers you can pull, is to keep your crop load low, so that you will continually gain pruning weight until you get up to that 3-pound vine. And then you can, optimize your yield at that 3-pound vine and try to maintain that 3-pound vine. And Nelson always preached that, you're cropping your vines too heavy. You need to, don't crop them so high so that you can gain pruning weight, and you're going to get future production out of that vineyard. Where in a lot of our vineyards now, like with the research that we've done over the last 20 years on nutrition and soil pH, a lot of our vineyards their pruning weight has increased to that 2.5, 3-pound vine, and now they're just trying to maintain that. So hitting a Ravaz index of 15 and maintaining a 2.5 to 3-pound vine is bringing home the money.
So would you say it would be fair to say that if you had a 3-pound vine and you had a higher Ravaz index than you were looking for, and it only came down 2.75, 2.5, you're still good. Like I wanted to know what is that without a
Yeah,
detrimental
if
effect.
so that Revaz Index study, that Concord crop load model study that we did, if you have a Revaz Index of over 20, and it's not unusual to see 30, 35, 40.
Holy
So
moly.
very different than, Pinot Noir growers in Oregon who, the Revaz Index is like 4 or 5. And they're like, if I hit 6, I'm overcropped. Concord growers are like 35 before they're overcropped. But you will lose pruning weight at that point. So if your crop load is too high, you're putting too much energy into the crop, not enough into the vegetation, so you lose pruning weight, and that decreases your yield potential for the next year.
Mm-hmm.
So, yeah, I mean, if I'm starting with a 3 pound vine and I overcrop it, and then like last year we had a drought, like you could easily drop a pound, on average, a pound or more of pruning weight. And then what do you happen? You come back with a mediocre crop this year. Sounds really familiar, doesn't it?
Sounds very familiar. Thank you.
Because that's exactly what's happening in our industry this year. Okay, we are really digressing off of nutrition. Go back. So my point here is, as an extension person, Jennifer, you could go out to a vineyard or go see a grower, do a farm visit, and you're standing in any one section of a vineyard, and you can ask questions. Well, what's your organic matter like in this area? And have you adjusted your soil pH? And what was the crop size here last year? And trying to help the grower decipher what's going on. And our role with the Nutrition Project and with the Efficient Vineyard Project is, we want to be able to measure this stuff spatially. So use different sensors and validation in the field to get spatial maps of supply, uptake, and demand, and then be able to make some decisions on variable rate fertilizer applications. And to me, it doesn't matter whether you're doing it on the whole farm, right? Or on a block by block basis, or on a spatial data basis. And we're kind of, from a research side, and a lot of our growers are at this area now, where you're collecting spatial data, you're making decisions on a much more, granular basis, and moving forward with variable rate management based on those maps. But it doesn't matter. So some people will say, well, I don't have sensors and I don't do the spatial data thing, so this isn't important to me. But if you're doing it on a block by block basis, to have an understanding of what the soil is supplying, what the vines are taking up, and what the demand is of those vines in terms of its vine size and crop size, is going to help you, even on a block by block basis, which is what we used to talk about all the time before we got into spatial data. Okay, so another major theme of the talk, or of what we do, is we take these relative sensors, soil, canopy, crop, and now nutrition sensors that are relative in nature. They give me a relative map, and I do some low density directed field validation. And the MyEV tool helps you look at that spatial pattern and says, go to these different areas and sample for your validation. And then you can translate that map. So in this example, we're using a late season canopy reflectance NDVI, get that spatial map. We take pruning weights, directed pruning weights based on that map, and then we translate it so that I can have a high density pruning weight map of that vineyard. And that would help me make decisions so in this red area, right, we have low pruning weight and low productivity. So I can also try and diagnose if there's any nutrition problems going on there that I would treat differently than the blue areas, which would be high pruning weight, high productivity, probably higher soil nutrient conditions in that area. So again, just the general theme is relative high density sensor map, directed field validation. And I laugh when I say that because people are like, really? Do I have to go out to the field and actually take it? It's like, yes, you do. If you don't have to, I mean, you can fly by the seat of your pants. You can take that spatial map and say, yeah, it's low in the red area. Yeah, I know it's low there. I would say they're probably 1 pound vines, and go with that. I mean, if that's what works for you, go ahead. But I'm a scientist. I'm going to go out because I want data. I'm going to go to the red area and I'm going to take some samples there to see if I really have low, or what is the actual metric in that low area. Is the red mean 1 pound vine, a 2 pound vine, a 3 pound vine? We don't know until you go out and measure it.
And then manage your decisions based off of it, right? It feels like
Yes.
we're going.
Yeah. Measure, model, manage. Okay, so how do we do this with soils? So we have a dual EM soil sled. For those of you in soil science, it's like an EM38, and it measures electrical conductivity and magnetic susceptibility at 2 depths, the way we have the array set up on that. And it gives you, so the spatial map on the right-hand side, the colors are from the soil sensor. If you want it, I mean, that's expensive. It's like a $20,000 sensor. And you probably, the best thing for you to do as a grower, because your soil doesn't change very much over time, is you just hire somebody who has a soil sensor that will come in and map your vineyard once, and you pay them to do that, and then you have that spatial map to work from. If you want to go the free route, you can go to like the NRCS Web Soil Survey, and you can download the soils map and pull it into my EV, and that's the lighter white polygons I have. So I just wanted to show the comparison. So this is our lab. It shows the comparison. So the web soil survey, or the old county soil map, some people call it, it does a pretty good job, right? It, in general, I mean, for somebody who is physically like making those soils maps on observations, did a really good job. But the soil slide just gives you a much more detailed map of how that soil, and where, especially the transition zones where soils may be changing within your vineyard. And then that comes into play in terms of nutrient availability and vine growth, and how you might fertilize that differently. So, but again, for somebody who just wants to get into it and they want to do this like on a free basis, go to the web soil survey. It's free. Pull it into my EV. It's free. And then you can go from there.
Are there any satellite sensors out there right now that can tell soil EC across blocks?
Yes, there are. You're getting out of my realm of what I
Okay.
will say is that Nick Gunner, the guy who's the software developer for my EV, so he built in a tool now where you can pull in satellite imagery. So whatever free satellite imagery is out there, like Sentinel-2, and what's the other one that we use all the time? I can't remember.
I always say Landsat, but that's the old
Yeah,
one.
so I mean, there are satellite imagery stuff that will give you soil stuff. I don't know. I haven't worked with it enough to know how good it is.
Cool. Well, it's an option for anybody who wants to
Yeah.
explore it. Yeah.
Yes.
Okay.
So this is a new vineyard planting that we did last year, or I think, we planted it last year. The soil analysis was done the year before. So again, same thing. We scanned this open field with the soil sled, came up with a pattern. We sampled against it. So really the photo, the soil pits photo, I'm standing in probably right around where this 4D sample is, looking back towards the building. So you can see I'm standing here looking back towards the building. So this is this field. And we did do some soil pits to see, again, we used this soil map to say, oh, I'm going to do a soil pit here. We did one here and we did one here to try to see what the differences in soil. But we also soil sampled across different areas and did some composite. So again, blue zone, red zone, a transition zone, and got a chemical analysis on that. So I could say, oh, this should be a low to moderate vigor, area, or this should be a high vigor area, trying to predict. And we planted Concord, Aravel, and Lemberger into this field. For Concord, we still went with own rooted because everything we do with Concord around here is own rooted. But you could. We've talked about this. Like, you could take a soils map like this and you could change up your rootstock selection based on what you think the vigor potential is going to be. Like, if you're going to have a very high vegetative growth area based on that soils map, you could, pick a more devigorating rootstock so that you can maintain those vines, or vice versa. If you're in a low vigor spot, you could go with a more aggressive rootstock and try to boost up that vine size. And some of our growers, so we get into this big discussion of tissue sampling and when to sample and what does the sample mean. And when we surveyed most of our Concord growers, they just go by soil. So a lot of our growers just will take this soils map and some soil sampling to validate it, and they will base their nutrition totally off of that. And they only take tissue samples if they think they have a problem. But if they really don't see any problems in, say, magnesium deficiency or potassium deficiency showing up on the leaves, they just go with their soils and move on, which again, I have nothing bad to say about that. Okay, so that was supply. I'm going to skip over uptake and go right to demand because most of the talk is about uptake in tissue sampling. But again, for those who have been following the kind of work that we do, again, crop load, Rivaz index of 15 to 20 for Concord or 8 to 10 for most wine grapes. We try to get a predicted yield. So we have found in Concord that bloom time or an immediate bloom, NDVI, canopy reflectance relates best with our yield map at harvest when we measure it with a yield monitor off of our harvester. So we leverage that we take our NDVI bloom, we get that pattern, and then we do a crop estimation sample at 30 days after bloom. So we do it with a machine. I know some people, pick clusters, count berries, everything. We essentially take a sample, roughly 1% of an acre, and we clean pick it at 30 days after bloom and weigh it. And let's assume it's 50% of final berry weight at 30 days after bloom. We double that weight, and that's what our crop prediction is. So we come up with a predicted yield map by doing that, right? We have a high density NDVI map. We do a low density but directed crop estimation sampling, and then we put those two together to come up with a predicted yield map for that vineyard. For pruning weight, this one is less solid, and we're trying to make it more solid. But we'll do a later season NDVI and relate that to pruning weight to get a predicted pruning weight. We're working with Rob Chancia, who hopefully you all heard talk at ASEV about the drone nutrient work that he was doing, but on the side, we're doing drone canopy fill work. So looking at, canopy fill is related to pruning weight. So we're trying to, relate all those things together to try to be able to fly a drone over the field and get a estimated pruning weight map in season of that vineyard. So again, putting those two together, yield to pruning weight ratio, I can come up with a Rivaz index, essentially just saying this is where the vines are overcropped, this is where they're undercropped, and this is where they're balanced. And I can make a decision on where the vines are overcropped if I want to do any fruit thinning in there to try to bring those vines more into balance. From a nutritional standpoint, I know that vines that are overcropped means they have too much crop for their vine size. I mean, that may be, a small crop on a very small vine or a very, very big crop on a big vine or a big crop on a small vine. It's, again, it's a relative thing between what the yield and the pruning weight is. It's that ratio. But I know if my Rivaz index is high, my ratio is off, and the nutrient demand, the crop nutrient demand is going to be high, right? I'm pushing those vines pretty hard, and I may need to supplement them with some more fertilizer to support that high crop load if I don't decide to thin it. Okay. So same concept, high density spatial data from a drone. So, hyperspectral and multispectral imaging done by Rob Chancia at RIT. Low density field validation, so tissue sampling, leaf blades and petioles at bloom and veraison. And I'll show two different plots that we did this in, and then we try to match those up. If we can get a good relationship between the spectral data and what the tissue values actually come back from the lab, those match up nice, so we can get a spatial nitrogen map, a spatial potassium map that then we can fertilize against. Okay, so how did we do this? First of all, this was really to help the engineers. We took a 1 acre Concord block, broke it up into quarter-acre sections, and we tried to induce nutrient deficiencies for the engineers so they could fly or use their hyperspectral tools, whether it's from a drone or handheld, in the vineyard. We tried to induce the nutrient deficiency so that their spectral imaging, we could actually, get some differences that we've induced, not just what's naturally there. Mm-hmm. So we have a low nitrogen block, it's had zero nitrogen since 2020 in some respects or some areas of that vineyard. The nitrogen deficiency is just starting to show up now, like 6 years later. So, that is one theme and it does depend on your soil. If you just stop fertilizing altogether. So most of the nutrients that you get from your vineyard or to your vines come from what's naturally occurring in the soil. Fertilizer is supplemental at best. Right. And
It's your vitamin, not your diet.
Right. Exactly. It's like your meat and potatoes are what's going on in your soil. And if you have a healthy soil and it's releasing nitrogen and potassium and everything. But there are times of the year where the vines are growing very quickly and that soil supply is not keeping up. And that's when fertilizers are very helpful. So like in this case, zero nitrogen for 6 years, and the vines are finally starting to show their nutrient deficiency. So when you do some of these trials, it takes a while. We want to see things. I think it's
also fair to say, sorry to interrupt you, that you do a very good job at cover cropping and building your soil health. So you've had a lot of those.
Yeah. And all your cover crop work. Yes. So it will depend on your soil and your soil management. So if I was in a very sandy soil with low organic matter, I could probably get that nutrient deficiency or that nitrogen deficiency to show up a lot earlier, maybe after 2 years. We've done work in some deep, heavier clay soils in this area with high organic matter, say 5-6% organic matter, right? We stopped applying nitrogen altogether, and 10 years later, still no nitrogen deficiency. So again, it's a balance of what's being supplied and what the vine demand is. And so in this case, we're on a gravel loam soil, about 3% organic matter. It's taken 5-6 years to really get the nitrogen deficiency to show up. Same thing with potassium. Man, I still probably couldn't go out and really solidly identify visual nitrogen or visual potassium deficiency in our low potassium block. Although the tissues are starting to show it. And then we have low soil pH generally in our region, so that's why we always include a low soil pH block in it, which ends up being low phosphorus, low magnesium, typical acid soil symptom type stuff. So again, no phosphorus fertilizer in that block since 2020. And all the little dots, what they mean is we have individual vines. So there's 100 vines, so 25 vines per sub block there. Individual vines where we collect leaves and petioles at bloom and veraison, have those analyzed, and then we send those to engineers to match up with their spectral data to see if there could be any differences. This is what the block looks like. That's Rianne collecting some tissues at bloom with her little helper. So it's been a big discussion. I'm not going to say controversy, but a big discussion, a scientific discussion among scientists on this project about what tissue to collect and when to collect it, right? So, and I think one of the things that we need to address in that conversation is what's the best tissue and time to sample to do what? Everybody wants, give me the one time to, so collect petioles or leaf blades at bloom, and it's going to tell me everything I want to know, and I can just use that in my management. And unfortunately, it's not that easy. So you're left with saying, okay, well, if I sample this tissue at bloom or this tissue at veraison, what's it really telling me about what's happening in the vines? And then how do I interpret that for use? So again,
Wait.
drink. Yep, drink.
Drink.
Sorry, he did a lot of good work.
He did. See, you're drinking.
So even when you go back and you read stuff from Nelson, so 1956, he did a whole thing on tissue sampling, and he says you're supposed to collect for nitrogen petioles at bloom, and that late season sampling told you nothing. And then he said, but for potassium, you wanted to take the fall sampling, because the early sampling, the potassium was changing so fast it couldn't tell you anything. So even back then, there was controversy over what tissue to collect and when. Or turn it around, it's not a controversy, it's a informative, hey, collect this tissue for this and another tissue for something else, depending on what your question is. Okay, so I always, to me, everything just comes down to very basic plant biology of perennial crops. So you're going to say something?
I was just going to say, I really appreciate this slide, and you've shown it a couple times during different presentations, and I think it hits home with the growers. So
yeah,
thank you for this.
Yeah. So this shows the grapevine annual life cycle or nutrient cycle. And so we start with a dormant grapevine. And so most of the information that I'm going to spill out of my mouth is based on vine excavation studies that we've done. So we had two real major vine excavation studies. One, we had some young 3-year-old Concord vines. When I first started working, there was a vineyard. It was going to be torn out. I said, wait, let me tear it out systematically throughout a season. So I think we did like 6 time points throughout a season and dug up the whole vine, separated roots, trunks, stems, shoots, leaves, just separated everything and had it analyzed for nutrients and carbohydrates. And then there was the information we got from that was so good, we decided to do it on a set of mature vines. So these were 30-plus-year-old Concord vines. Again, back in Fredonia, there's a vineyard that was going to get torn out. So we excavated 10 time points throughout a growing season. Again, separated the vine into all its different structural parts, ground them all up, had them analyzed. So most of what I'm going to say comes from that. So what do we know is that in a dormant grapevine, roughly 50 to 75% of all the stored reserves are in the root system. So the nitrogen, all the starch. I always say there's an old saying that you can't kill a grapevine with a pair of shears. And it's because even if you cut the vine off at the ground, again, this is own-rooted Concord. We're not talking about grafted vines. Cut above the graft union. If you cut a vine off at the ground, it still grows back the next year because most of its growth potential is below ground. And really what happens in the spring is you're getting remobilization of those nutrients and that stored carbohydrate to grow new roots. And a lot of that stored reserves actually goes out of the root system as root exudates to help the microorganisms in the soil, feed the microorganisms to help release nutrients, to help more nutrient uptake for these fine new roots that are growing. Plus a lot of energy goes into growing new shoots and at least the blooms before pre-bloom, just getting into early crop development. So you get this remobilization, and we see very little. So we've done work with Lei-Lang Chang at Cornell on non-radioactive isotope nitrogen fertilizer. And we will put it on right around bud break, and then we'll watch it through the season where the nitrogen fertilizer, when does it get taken up and where does it go? And so we see that like less than 5% of that nitrogen fertilizer gets taken up in the vine prior to bloom, right? Most of it gets taken up after bloom. So from bloom to veraison, the vine goes through an assimilation period, right? You're acquiring carbohydrates through photosynthesis, so that's assimilation, and you're acquiring water and nutrients from the soil. And most of that happens from bloom to veraison, especially in Concord, in New York, where we have a short growing season. I mean, it's 70 days from bloom to veraison. That's all you got to take up your water and nutrients. And that's when we see all of it being taken up. And then veraison is the onset of ripening, and then we really start talking about crop load. Your yield to pruning weight ratio. So how much of that energy that the vine is taking in gets shuttled to the fruit or to the wood. And we see very little nutrient uptake after veraison. And I know this is different from looking at other excavation studies in longer growing season areas, where they do have a significant like post bloom period that you can get a lot of nutrient uptake after like the crop is off. You still might have a month of photosynthesis and nutrient uptake. That's not the case in New York. So we go from veraison, the fruit ripens, and at harvest, sometimes we harvest the fruit and the next day we get a frost and the season is shut off at that point. So again, early season, we remobilize our nutrients from bloom to veraison. We assimilate all of our new nutrients from veraison to harvest. We partition those nutrients into the fruit or the wood. And there's very little new nutrient uptake at that point. And then from after harvest, when the leaves start to senesce, we get nutrients that are stored in leaves that get remobilized back into the storage tissues when get ready for next season. Okay, so we decide we're going to take tissue at bloom or veraison. And so there are two completely different times of the season. If we look at this is total vine nitrogen, again, from the vine excavation study. So the blue line is total vine nitrogen. So the vine actually starts with nitrogen because it's stored in the root system, gets remobilized. We see a loss in nitrogen because I think a lot of it is getting pumped out into the soil. And then from around bloom to veraison, it's all the nitrogen that the vine's going to take up that season gets taken up that. This red line at the bottom is that nitrogen fertilizer. So again, prior to bloom, we have very little nitrogen from fertilizer uptake, and after bloom is when it all happens. And then post veraison, we get very little. Right. So again, we're taking tissue at either bloom or veraison, and based on what we know about vine biology, what do we think that's going to be telling us? That's the nitrogen that comes from fertilizer. Okay. You're going to say something.
I was, but it's going to take us into another. If you could go back a slide.
Yep.
That is a great visual to see. The blue line, which is coming from the vine itself and everything that the vine is doing, not coming up from synthetic fertilizer that somebody has put on.
Yep.
That's from 30 to it looks like about 65, maybe a little bit higher than that. And
yep.
The nitrogen fertilizer, which is what you could actually take up that you have found by tagging fertilizer and being able to follow it through the plant, goes to what, maybe 7 or 8?
Right.
So yeah, I really like that visual. Sorry, I know it hones, it like drives home the stuff that you're
very astute. Yeah. So again, the take home is most of the nutrients that you are taking up are coming from the soil. What's the reserve is in the soil. It's affected by water. It's affected by microorganisms. How healthy your soil is. So active organic matter. That's your meat and potatoes. And because the vine is growing so fast during this period, that meat and potatoes is really good, but there might be times when it's just not enough. And so you need a vitamin. But I hear growers say a lot, you got to feed your vines. And it's like, yeah, well, you feed them through the soil, but don't feed them with fertilizer. So I think that's just, I think there's a little misconception out there about how much fertilizers do. Right.
Yes. Thank you.
They are supplemental at best, but they can be a very needed supplement during rapid growth, especially.
Obviously it is here. There is a bump in it. So
yeah.
Okay.
Yes.
Thank you.
Okay. So what is the data to support collecting leaf blades at bloom? Because this was the hot controversy, right? So you probably heard people talk at the ASEV meeting about the coefficient of variation, and that in leaf blades, the coefficient of variation is lower than it is in the petioles, which is an argument to say that they are more they're a more precise measurement of vine nutrient status. And when we looked at our Concord stuff, we saw the same thing. So I think there's more similarities than differences. We also had lower coefficient of variation in the blades than the petioles.
May I ask you to those are really big words, like for people who aren't
Yeah.
scientists.
So, um, yeah, okay, here's an easy way to explain it. Say you're taking the average weights of elephants and the average weights of mice, right?
Okay.
And they're going to vary. The elephants are going to vary, have some variation, and the mice are going to have some variation. And you can't really, it's hard to compare because elephants are so big and mice are so small. The coefficient of variation normalizes that and says, like how much does the mouse vary based on the typical weight of mice and how much do elephants vary based on. And so the same thing with tissues, like when you take leaf blade tissues, the values tend to be much higher and petioles tend to be much lower, and they both vary, but like what's the relative variation of those? And they're saying that the leaf blades vary less. So if you
Okay,
take
thank
two
you.
samples that are the same, right, and it's just that the nutrient concentrations in the leaves vary less than the petioles. The second kind of piece of evidence is, so in those 100 vines that we have in that one trial that we collect pruning weights and tissue values off of, we see a nice relationship, somewhat nice relationship. It's a R of 0.5 and 0.6, so it's not
Yeah.
fantastic, but it's better than nothing. So we do see a relationship between vine pruning weight and bloom, leaf blade, and petiole nitrogen, but we don't see that in veraison. So you're like, oh, okay. So there's some evidence that, and I can see now why Nelson Chalice would say something like that. That yeah, drink again. That if he was really big on looking at vine vegetative growth and pruning weight, and then he collects bloom time nitrogen values, whether it was petioles or blades, there is a relationship there. So it is telling you something about the vineyard, where the veraison sampling and comparing it to nitrogen tissue values, there's nothing there. Like, I mean, that's yeah, that's a buckshot
Yeah.
for those who know what a buckshot is.
We're in Western New York. We know what buckshot is.
So somewhat of a relationship at bloom, no relationship at veraison. So again, lower coefficient of variation in blades. Blades are also telling you something about pruning weight. But I also have to say, at bloom, petioles and blades also relate, at least in our data, they relate with each other. And I think you got to think about what's happening at bloom. You got new shoots are growing. They're very vegetative and fleshy, and the petioles are fleshy. The leaves are fleshy. You're literally collecting the leaf blade and the petiole and then separating them, drying them, grinding them, and sending them off for analysis. And they come back with similar relationship to each other, and then they also relate to pruning weight. But at veraison, we don't see that. If you take a leaf blade and a petiole and you detach them and you dry them and grind them and send them for analysis, they don't really relate that well to each other. And so I think there's, people talk about the petiole being a straw and it's very transient, and then there might be more lignin in there. It's started to harden off, where the leaf might be more fleshy and more of a sink organ. So that's why they might be different at veraison. Okay, so now let me give you some evidence to support petioles at veraison. And this, again, comes from our study where we're trying to induce nitrogen, potassium, and low soil pH or low phosphorus vines. And so when I compare the healthy check ones, so the vines that we've given, lots of nutrients to, so full complement of fertilizers every year, that's the black line in terms of nitrogen, potassium, and phosphorus, compared to the low nitrogen block, or compared to the low potassium block, or compared to the low phosphorus block. We see, even in the initial year where we withheld nitrogen, we're already seeing lower petiole values at veraison. in the year of. So, I was talking about, oh, we have this block. We haven't applied any nitrogen since 2020. And like, we're just starting to see nitrogen deficiency show up in the bloom samples. But in the veraison samples, we've seen it since day one, the year we initiated changing the fertilizer. So again, I think that's what's at bloom, you're getting what was stored in the vine, which it's a perennial crop. And if it's got lots of reserves or it had time to pick more up from the soil, you might not see the nitrogen deficiency. But the veraison samples are telling you, hey, I saw low nitrogen during the middle of the growing season when I was trying to take up nitrogen. And we're capturing that in the veraison tissue samples. And it was for all three nutrients. Okay, so so again, we compare. So this statistical analysis is comparing the control vines that have all the nutrients versus the ones that either have low nitrogen, low potassium, low phosphorus. And we don't see, so all the NS just means is not significant. So we don't see differences between the control and the treated in either bloom petiole or bloom blade, right? We don't see the difference until we're starting to see it. We didn't see it in 2025 for nitrogen, but we did see it for potassium and for phosphorus. So again, takes a while to get things to happen. And we did collect the tissue this year. So it's like, did we finally push them over the edge? We're hoping to see that. But again, since day one, we've seen this difference in veraison petioles for nitrogen and especially for potassium and phosphorus. And we also see it in the blades. We didn't see it for potassium in these years, and we didn't see it for phosphorus in 1 year. But here, again, you see a lot of stars on this side. You don't see a lot of stars on this side, meaning that the veraison ones are showing us that there's nutrient uptake differences. I don't even want to say deficiencies.
Just differences. Did you correlate that with weather and everything when you were looking at this? Or doesn't it matter?
You see this one gap year in 2024 was a frost year. So we collected petioles, but we didn't collect blades because we probably should have, but we didn't.
Got it.
Yeah, we can always go back and correlate it with weather conditions. Okay. So this is kind of getting off track a little bit, but it's cool just to see it visually. I'm going to show you this visually. So here are 100 vines. The size of the dot is related to the nitrogen that's in the vine, right? So this is bloom petiole, bloom blades, veraison petiole, veraison blades. And these are our control vines that have lots of nutrients or should have lots of nutrients. And then these are the low nitrogen vines. So again, if we go back, we saw no statistical difference between this one and this one in the bloom samples. But we did see very significant difference in the petioles at veraison. And they're like these are really small compared to like these ones have lots of nitrogen, these ones don't. In the veraison petiole, we did see a statistical difference between the veraison blades, between the control and the treated or the low nitrogen vines. And I think this is my interpretation of this. Again, the petiole is a straw and it's seeing like that very short time frame, like a few days around veraison. You went, you picked this tissue, the tissue was, sap was going through that tissue, and whatever the vine was experiencing during that day or 2 days or that week is what is showing up in the tissue samples. So if it's like, oh, it's veraison and I'm really under low nitrogen conditions because whatever, I haven't had any nitrogen fertilizer and it's a drought and I have a high crop or something, like it's really low. Where I think the blade is giving you more of a longer period of time from bloom to veraison. Like this is the accumulation of nitrogen in the blade during that assimilation period. So like So now I'm torn. We've always done petioles, and I think it's because if you have a problem, it's going to show it. To really maybe understand like what the assimilation of that nutrient was, it might be better to do the veraison blade because you're capturing what was happening during that whole season. That might be more informative. But if you just want like a red light, green light, still go with veraison petioles because it's pretty obvious.
Yes, it is. And just by looking at that.
Okay, so again, say what I just said. So if you're looking at relatively stable patterns in the vineyard, right? I have, I know I have like good vine growth on one side of the vineyard and low vine growth on the other side of the vineyard, and I think it might be related to some nutrient. You can take your bloom time samples because I think that if it's a stable pattern within the vineyard and a nutrient is causing it, I think it's okay to take bloom time samples. If you want to know kind of like what's happening to your vines, even if your vines are not showing any nutrient deficiencies, if you kind of want to understand, okay, this is what they're experiencing right now, go with the veraison sampling. And if you want a tighter window, go with petioles. And if you're looking at a wider window, go with blades. That would be my interpretation of it. I don't know if there's viticulturists around the world right now going, he's full of it.
I thought you were going to say go with
I'm getting
blades.
too old to care, I think. Okay, so let's move on. That was my spiel about petioles at bloom and veraison. Okay, so again, our whole deal was we set up these vines. So here's that block where we collect our different 100 vines. So we have low nitrogen, low potassium. That's all right in this little block right here. So Rob would come from RIT at Bloom and Veraison and fly his drone. So they started off with doing all the hyperspectral imaging, and then they went to multispectral imaging. And he created some of these models. Again, relative models that then he can give me a pattern in and then I can sample against. That was the kind of the whole idea. And so again, from a variable rate fertilizer, if I can get a spatial map of soil, I can use Rob's nutrient sensor, relative nutrient sensor, and then like a yield map that we predicted or actually have been harvesting for several years to get a pattern in that field. Like I can use those, I can smash them all together and use them to come up with a, management map. I do that in my EV again.
I did have a question. Of course,
yes.
I had a question. Was Rob able to make a correlation between the manipulated potassium, nitrogen, and phosphorus with wavelength?
Yeah, so you'd have to re-listen to Rob's talk because he's smarter than I am. But so these are models built. So this is nitrogen, bloom and veraison, and potassium, both bloom and veraison, I guess. Is what all means. My face is in the way. Yeah, all data. So he built these models using blue, green, red edge, and near infrared wave. So multispectral. So they went away from the very expensive hyperspectral camera, just went with multispectral, and built these models. And they're pretty good. He's like, oh well, they're not tight enough, and I'm like, for field work, those are pretty good. That's a nice relationship. So yeah. So I think we're at the point where he can give me a relative nitrogen map of a field, right? I know it's low over here and it's high over there. Now I can say, ooh, I'm going to go sample in the low and the high, compare that with what's published in the Wine Grape Production Guide for Eastern North America by Tony Wolf. Shameless plug. That's where we put our tissue values. Compare it and see, okay, is the low nitrogen section low enough for me to take action? And vice versa. So yes.
So using a sensor to make a variable rate nitrogen application.
Yeah, so we should be clear that it's not telling you, like, you're not going to get a spatial map and then it says, you have 1.2% potassium here. It's going to give you a relative map of low, medium, and high, and you have to go determine what the low, medium, and high is. So some of the work that Ali was doing with the hyperspectral, the gun,
Yeah, we saw him
right?
plugging on some
So
leaves.
in that case, the hyperspectral instrument that they used in the field, I mean, that existed before this project started. To Ali's credit and his team's credit, what we didn't have were the models, and they did a heck of a lot of sampling, and they even came out and they did some work in this block. So they did a lot of sampling to build the models to say, oh, if I get this, basically this hyperspectral thumbprint, it will tell me what the percent nitrogen is or the percent potassium is. But from a practical standpoint, right, it's very expensive. It's a handheld thing. You walk around the vineyard, you got to clip on a leaf. So it might be a great tool for like a consultant or somebody who is, if you hire someone to come and do nutrient sampling in your field and have to collect samples and send them off to a lab, and it's time, and this could be, hey, I come out to your field and I clip onto leaves and I'm getting those values for you. So that's really cool. From our perspective of variable rate, I'm trying to get a variable rate map. Again, I'm just following the same kind of procedure, relative map, in-field sampling that's directed, so it's lower cost, lower time. Have those samples done and come up with a more solid viticulture, like a nitrogen map or a potassium map that I'm going to use for my variable rate management. Okay. I'm not going to talk more about my EV. Okay, so I will mention this because it is a tool out there for Concord growers. I will say that if you're a Cabernet Sauvignon grower in Lodi, don't use this because I'm not sure it'd work. It might relatively work for you, but you need to adapt it to your situation. Okay, so we built these nitrogen and potassium fertilizer calculators, and they're online. They're on the Efficient Vineyard site. If you go to the viticulture blog, they're right there. And you can use these. So what they are is, again, we're trying to capture supply, uptake, and demand. So you take values off of your soil tests, like percent organic matter will help you with your nitrogen. For potassium, it's going to rely a lot on your soil pH and the balance of calcium, magnesium, potassium. So you take those values off of a soils test that gives you your supply. You just plug those into the calculator. Then from a demand, you can either go out and measure this stuff, or again, you can fly by the seat of your pants and say, yeah, I'm looking at this part of my vineyard and it's, it has 2.5 pound vines, or it only has 1 pound vines, or what the crop size was last year, or what you think it is this year from your crop estimation. Do I have 5 tons per acre, 10 tons per acre? And again, a lot of this information on the demand, nutrient demand, comes from those vine excavation studies with Concord. And then putting those two together, it'll give you a maintenance rate. So I put this in there because our growers, this is how they talk to me about it. Like, what's the maintenance rate of nitrogen I need in my vineyard? If I have 2% organic matter and I'm running 10 tons per acre, what do you think I should be just putting down just to replace the nitrogen the vine is taking out? I don't actually think that's the way it works, but that's the question I get asked.
I get asked it all the time as well.
Yes. So, yes, we need to have another nutrition talk. I'm like, how does this work? So it gives you a maintenance rate. So just, yeah. And again, a lot of our growers, this is what they go on. They go on their soil tests, and they go on like how well their vineyard is producing, and they say, what's my maintenance rate? Then if they think they have a problem, they're starting to see some nutrient deficiencies crop up, or their yield starts to track down over a couple of years, and they're like, hey, I think I might have a nutrition problem. Then they'll go out and take some tissue values, and that will lead into like, what is your vine taking up? The classic example from our area is my soil test says I have enough potassium, but I see black leaf potassium deficiency on my leaves, and I'm having a hard time getting my crop ripe. And now they go out and they collect, veraison. The next year they collect veraison tissue samples, and so it'll tell them, a corrective rate of either nitrogen or potassium based on those tissue values. And again, maybe those tissue values need to be tweaked based on all the information that's coming in from this project. Again, I'm just using ones that we already have. I don't really feel like there's anything that has moved the needle with a Concord growers yet. So again, this is a free open calculator. So it tells you, okay, this is how much nitrogen or potassium you need. And it gives you a cost. Like you can click on what are your different fertilizer sources, and it'll give you what the cost is based on what kind of fertilizer you're using. So let me talk a little bit about the actual variable rate fertilizer trials that we're running. So again, from a soil sled, we're coming up with nutrient supply. Uptake is from Rob's drone flight over the vineyard plus some sampling. Demand is looking at yield and pruning weight in there. So by putting those values spatially, putting those values into the calculator, I can come up with a maintenance rate of N and a corrective rate of N. And I slap those two maps together and come up with a prescription map of how much urea I should put on that field in a variable rate application. How do we do this? So we do it two ways. One, we use a commercial system that's already available. So you use ag leader. So I will take that variable rate prescription map. I will export it out of my EV. I will import it into ag leader SMS software, which is the proprietary software of that company. And that prescription map goes into their 1200 unit computer, whatever, in the in the cab, which has the different urea rates on it, and that talks to a variable rate hydraulic valve. So it's a PWM hydraulic valve on this Lanco fertilizer spreader. And what that hydraulic valve does is it controls the speed of the chain at the bottom of the hopper. So if I want more material to come out, we speed the chain up, and if we want less material to come out, we slow it down. And we do like a bucket catch test to calibrate it to make sure that it's right. And in fact, we just did this like a couple weeks ago, and we just used the settings that we used last year, and it was dead on. So we had to do very little work to like calibrate it and have it ready to go. And then we drive the field, and there's you'll see a video of it. So it has the prescription map, and we just drive it, and it puts out more or less fertilizer where we want it to. The second thing we did last year, and it kind of has stalled this year because we lost our person working on it.
I see that person down there.
Yeah, to a good job. So a lot of our growers said, yeah, well, this whole get up cost me like $35,000. And, I have a 10-acre vineyard. I'm not spending $35,000 for my 10-acre vineyard. I can go out there and just shake it with a coffee can. And they said, can you take my Vicon cone spreader that I've had since 1965, and can you make that variable rate? So we did a little work, or we should say Owen Bates, yes, familiar last name, who's an engineer who now has graduated and moved on to bigger and better things. He developed this Vicon adaption. And he worked with Nick Gunner again. So Nick is the guy, he's the mastermind behind the MyEV software. And he built a MyEV, a variable rate plugin, which is open and available now on the platform. So you can have your variable rate prescription map. You can assign rates to these different zones, right? And then we built a little in-cab monitor that runs MyEV right out in the field. And that talks to a linear actuator that controls the orifice on the bottom of that cone spreader. So as the tractor drives through the field, it's reading the map, and it translates the rate into opening and closing that aperture, which delivers more or less material out the back. Again, we have to do like a catch test to calibrate the machine, and then once it's calibrated, we are ready to go. And next, I have a video of it going. You had a question?
I do have a question, and it's not to minimize any of this work whatsoever. I think all of this is genius and needed, and it's where we're going to. But let's say you obviously can't afford a variable rate because you are that 10-acre grower and you don't have the cone spreader. Could you potentially just slow down or speed up to variable rate apply fertilizer in your field?
Uh, yes. It depends on if your spreader is going to adjust to your ground speed or not.
I
Some
just
will
think that the
automatically adjust to your ground speed. So, well,
so the map is genius. It tells you when you can
yeah.
go a certain speed or
So here's one way you could. So let's see. The way we built this is there is where this linear actuator is right here, this red circle, this linear actuator. There actually is a handle there that kind of turns it on and off. And that's the way growers have been doing it in the past, where if they're like, oh, I'm traveling down the road and I really don't need a lot of fertilizer here, they'll like reach behind them and shut it off. And then when they get to a spot where they want to put fertilizer down again, they open it back up. So it's instead of variable rate, it's kind of more of an on-off thing. Also, the other problem is they'll either turn it on or shut it off, and then they'll forget about it, and they'll be like, oh, I wanted to shut that off. I want to turn it on. But what you could do, if you were doing that, what you could do is you could run My EV on your phone, and it will it'll track your location. So you could have the map, and you could be looking at the map and be like, oh, I'm in a blue zone. I want to put down more fertilizer. So either open it up or slow your tractor down so that you're actually putting down more fertilizer. And then, oh, I'm in another section where I want less, so speed up or shut it off. And you could do that manually. Yes, absolutely.
so that information is still valuable even if you don't have
Right.
the bells and whistles.
Yeah. So, yeah, we don't have Owen anymore, and I don't have the brains to do this. We just need another student to work on it, to kind of finish it off. If there's that much interest in it, we'll get somebody here next summer and finish the job. But it's possible, and it's cool, and it worked. You'll see here in the video. So here's our Lanco spreader. Again, this is our mainstay. I mean, this is what we've been really doing the variable rate fertilizer applications with. And again, so this is from 3 years ago now. So that's what the map looks like in the Ag Leader system. And the yellow zone is a lower zone, and you'll see this. It's running on My EV. So you hit this green zone, and the chain speeds up, and you dump out more fertilizer. I think I have a new video from this year, but it looks exactly the same as this one. And then the next video. Okay, so here's our Vicon. So again, this was last year. We did the variable rate fertilizer with this. So these strips we have in the vineyard, the solid strips are like a low uniform management. So like a maintenance rate uniform. And then when you hit the pattern colors, there is our variable rate sections. And we're comparing uniform management versus variable rate management. You'll see when it hit that higher rate zone, the linear actuator opened up, and now it's dumping more fertilizer out the back. And this is what Dan sees from the cab. So it's tracking on the screen, is tracking where he is. So he knows, oh, I'm hitting a high zone. I should start hearing that fertilizer spreader open up. And that should be about it. So I know somebody is going to ask the question, because I would ask the question, well, is it working?
I was just going to say, you did it last year, correct?
So again, I think this is going back to, hey, if you completely shut off your fertilizer, it's going to take several years before you start to see a difference. And in this case, we're not completely shutting off the fertilizer either. We're doing like a low uniform rate versus a variable rate, which has very high rates and very low rates all within a strip. But having said that, I'm starting to see a difference in the NDRE signature. So we measure NDVI, NDRE, and then sometimes we'll divide NDRE divided by NDVI. It's called CCCI or something like that. It's like a chlorophyll index.
I was
It
gonna say we
basically
all
will.
just glassed over on that
Yeah,
part.
yeah. I mean, it basically, if the leaves are starting to turn yellow before your eye can see it, the sensor will pick it up. And that's what we're starting to see. And I'm starting to see, like, I was really surprised to see that I just made the map the other day, so I should pull it up and, like, you see the cutoff. It's like, oh, this is right. This was the uniform strip, and then here's the variable rate strip, and all of a sudden it like lights up, and you're like, holy moly, it's working.
Hit the
So
pause. Holy
holy moly.
moly.
Yeah. Holy jinkies, Batman. So I do think we're starting to have an effect down there, and we'll keep doing it until we see something cool. Maybe we'll get a big rainstorm and it all wash out. I don't know.
Stop. So, what would be your takeaway points from your part of this SCRI for the high res nutrition that you honed in on? I know what I would say looking at what you presented today, but what do you want the listeners to take
Oh.
home from this?
I if you really want to, I mean, if nutrient management's a thing for you, it's a thing for me. I'm a plant nutritionist, you know. I mean, some people just don't care, right? They're like, yeah, I'll put down 50 pounds of nitrogen every year, whether I need it or not. It's just not your thing. Then fine. But I mean, if you're really trying to dial in, you know, some precise management, not just nutrient management, but I mean, if you're really trying to dial in the management, you're a good viticulturist, you're dialing in the management of your vineyard. I think variable rate everything. I mean, variable rate pruning, variable rate fertilizer management, variable rate irrigation. Even though we don't do any irrigation, not variable, because you can make it rain. I mean, it for all the years I've been working on it. I mean, it works. It does. You start doing variable rate, like what we're seeing in the nutrition study is you're bringing up the low vines. So we have small vines and we're doing the variable rate management. So we're putting a little bit more fertilizer on those weak vines, but the strong vines don't need it. So we're saving that. We're probably, we're preventing more fertilizer from going into the groundwater. I mean, so there's other, so the take home message would be like, you don't have to do it. You're probably not really causing anybody any harm. But if you do it, you're going to see some cost savings. You're going to see some environmental impact. You're going to see some viticulture impact. I think it's really good. If you're doing nutrient management, supply, uptake, and demand. That's always my number one take-home thing with nutrition is have an understanding of nutrient supply, uptake, and demand. It's usually one of those is screwed up is your answer. Yeah, so what were the big themes of my talk? Supply, uptake, and demand. If you're working with spatial data, at this point, I still think the best thing is you get relative high density spatial data, validate it against some infield measurement. It's still, the best fertilizer in the vineyard is a grower's footprint. Make me want to gag. But I mean, that is kind of true. Like you have this spatial map, leverage it to do better sampling in your vineyard so you have better management. Yeah, those would be the big ones. Supply, uptake, and demand.
That's what I would have said as well.
Yeah, supply, uptake, and demand. Have a good understanding of that. Just leverage that spatial data to do better management. And the variable rate management application part of it, it just has multiple benefits. I think it will pay off. I think with the fertilizer stuff, it's not like, oh, I did this and I see the light bulbs went off. It's like fertilizer is supplemental at best, and it's going to take a while for it to happen. But if a vineyard is a long-term, whatever management thing, it's a long-term thing. And I'm not speaking to the choir out there. So you got the time and start chipping away at it, and you're going to see big benefits. I mean, we do have growers that I think have been here. You hear me say this. I've been here a long time. And it's just in the last couple of years where I have heard growers saying, I don't know what to do. My vines are too big. Like, we have always suffered from low production and not enough vegetative growth. And growers are like, well, I don't know what to do. I did all this variable rate management. Now my vines are big and they're healthy. And I don't know what to do. How much fertilizer? I'm like, well, cut way back on your fertilizer. Like, what? I don't know. Cutting back on my fertilizer now.
I can't do it. It's been what I've been doing forever.
Yeah. It's all biology.
I think you've been doing a great job. What can we expect to see from you in the future?
It's all math.
Ugh.
Does anybody get? Nobody gets that joke. There's a movie, Jennifer Lawrence in it. It's called Don't Look Up, and it's all about
a great movie.
Yeah, right. The world's gonna end, asteroid's gonna hit, and everyone is. And he goes on the news, and they're like, "Don't talk about math." It's like it's all math.
And don't listen to the scientist.
It's all math. What can you expect from us in the future? So yeah, we're big push right now is automation in the vineyard. So we've done the vine biology thing almost to death. We've done the vineyard mechanization thing almost to death. And the next step is this automation stuff, right? We really got to find the next lever for growers to pull to reduce labor costs. And we are working with Yuzhong on some of these Amiga platforms to do simple tasks in the vineyard, automating just simple tasks that will help the growers out. We're going to start a project. We just got funding to start a project where we're trying to outfit our, they're calling them RECs now, research and extension centers, with autonomous capabilities. So we wrote it up as a 3-tiered thing. So this Amiga platform, the base platform is like a research-based thing. So, Yuzhong is doing like multiple robots, swarm robotics, all this cool stuff. Katie Gold is putting her sensors on there, her whatever, plant patholobot, whatever. So very research-based. What can we do? What can we sense using these autonomous platforms? And then the next level up is some of these more robust autonomous platforms. So we can do stuff like mowing and weed spraying using autonomy. And then the third thing is we're hooking up with a company called Agtonomy that has a 112 horsepower tractor that's autonomous that we can start hooking up some real vineyard implements to. And yes, we're trying to find some research dollars to help build a mechanical pruner that will go on the autonomous tractor. So we can, it's not going to happen in the next 2 years, but think future.
Well, that's what research is.
Maybe in February you can send an autonomous tractor out and do your mechanical pre-pruning for you.
Wow. I have seen the little robots on football fields when you drive past them mowing the football. So it is there, right? We could be doing it.
Yep. So we've been working with we got the Amiga, 2 seasons ago. And then last season, Owen was here and he was working on it and had built a navigation system that helped plant the new tech vineyard. So we planted a vineyard with the robot. And now Yuzhong and his student have their own navigation system. They put that on this year, and we've been trying to get that to work. And Akshay is a technician working for me this summer. Just today, got it to drive through the tech vineyard without crashing into anything.
Wow!
Yeah, so we're finally cooking with butter on this thing.
Fantastic. Well, thank you again for joining us. We'll make sure to push this out to people who were at A7 and may have missed this during the High Nutrition Symposium. I appreciate you taking the time to do that.
No, thanks for having me on.
Yeah, and then we will also push out. Wait, what?
Up uncontrollably.
Oh, I didn't want to bring it up. I felt so horrible for you. Well, thank you. I'm glad you're not doing that anymore. Yeah. And Andrew, is there anything you wanted to add?
No, I just got to enjoy listening to the presentation today. I didn't have too much to contribute.
Half of it could go on the cutting room floor.
No, no, no. The whole thing is going out. So thank you again. Please stay tuned for our next episode coming up. We'll have one next week where we're going to have Meg and Luke talk about the sprayer technology day that's coming up and what people can expect to see from there. And again, thanks for your time, Terry. We truly appreciate it. If you guys have any future podcasts that you would like to hear about or video blogs that you would like to see, send us an email. You can find our contacts online at lergp.com, and we will try to make that happen for you. All right. We appreciate you listening, and we will see you next week. Thanks, everyone.